Hey everybody, it's Mr. Carr again. Today we're looking at 5.4 day one. We're evaluating nth roots and using rational exponents. Okay, so when we talk about nth roots, what we mean is we might not always just take the square root, like 16, square root of 16, you've seen that before. So first thing is, what does this symbol mean? The symbol means we're trying to find what number times itself would give me 16. So because 16 is 4 times 4, the square root of 16 is 4. Okay. If I do the square root of negative 100, again, the idea is what two numbers multiply together give me negative 100, but they have to be the same numbers. So this would be something like 10 times negative 10. That doesn't work. So if I'm just evaluating the square root of negative 100, this is no solution. It's not possible. Okay. Or it's undefined, I guess. Okay. It's technically imaginary, but we're not going to cover that here. Now we get to these other root numbers. Okay. The cube root, we are asking what number times itself 3 times would give me 27. So if I could split this up, for example, if I do 9 times 3, 9 is 3 times 3, and then another 3. So 27 is 3 times 3 times 3. Well, that is going to give me 3 then as an answer. And you can do this in a calculator, but just to see how this looks. Here's where things might be a little weird. What number times itself 3 times gives me a negative 64? If I split that up real quick, I can do something like, excuse me, negative 8. Actually, let me do this differently. That's going to be, let's do negative 4 times negative 16. Or sorry, positive 16. Okay, so negative 4 times a positive 16. Well, then I can split this up. So negative 4, I'm going to keep. Negative 16, I can actually make that from negative 4 times negative 4. So in a way, I could say that negative 64 is negative 4 times negative 4 times negative 4. That is 3 numbers that are the same. So this does equal to a negative 4. That is an important thing I'm going to come back on just in a second. If I look at the fourth root of 81, what number times itself 4 times would give me 81? That's going to be 3, because 81 would be like 9 times 9. And then now each of those will split up into 3 and 3. So 9 times 9, 3, 3, 3, 3. Negative 32, we're looking for a number multiplied 5 times to give me negative 32. Because it's a negative number, it will be a negative here, and that's going to be 2. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. The thing I want to highlight with that, we are allowed to take, like you can take, yeah, I'm running that, can take odd uh odd roots of positive or negative numbers. Okay, so you can do the odd roots of positive or negative, but you can only take even roots of positive numbers. Okay, so you can only do positive numbers if they're even roots, like square root, fourth root, and all that. If real quick I look at like the nth root of 0, we're saying what number times itself, how n number of times is 0. That's just always going to be 0. It's 0 times 0 is 0, 0 times 0 times 0 is 0. Like that doesn't change. So if you're ever taking any root of 0, that's just going to be 0. All right, let's take a look at something that's a little bit different here. So we want to evaluate using a calculator. Whoops. What do you notice about using our fractions as exponents? So in a calculator, if you plug this in, 81 to the 1/2, this will just turn into a 9. Oops, let me write that down. 8 to the 1/3 would come out to 2 when I plug that in a calculator. So what's happening? What's basically a way of writing this is, think about what is 81 compared to 9. Well, if I do this as 9 to the second power, that's the same as 81. And that's going to be raised to the 1/2 power then. Well, what do I do when I take an exponent and I raise it to another exponent? Well, we multiply those. 2 times 1/2 gives me 1. there's 9 to the first. Same idea here. If I think about 8 and 2 and how they're related, well, 2 to the third power, 2 times 2 is 4, times 2 is 8. 2 to the third power is 8, so that's the same thing as that. So I take 2 to the third to the 1/3 power. These are also going to cancel each other out. So I end up getting 2 to the first power. So we get something that's very similar to our square roots. But here's the big idea. If I have a rational exponent, that's what this is called. It's a rational exponent. So it's got some kind of a fraction to it. The denominator is always going to be my root number on the outside, and my numerator is always on the inside, okay? Or it goes with the x. So if I want to rewrite 9 to the 3/2, that is the same as the square root of 9 to the third power. Now, one thing to do with this, if you could still plug this in the calculator, you just use a fraction for your exponent. But I can also just, instead of me doing 9 to the third power first, I can kind of do this. I can evaluate the square of 9, which is 3, and then that value will be raised to the third power. So 3 times 3 times 3 is 27. So that's what we're looking at with this. We're dealing with our rational exponents and what they mean. So one of the big things is we can always take a rational exponent and turn it into a radical. I feel like sometimes that makes it easier to evaluate, especially if you don't have a calculator. So for example, 16 to the 3/2 and 32 to the -3/5. So we want to first rewrite them as an nth root and then evaluate that. So 16 to the 3/2, this is the same as having a 2 and then 16 to the third power. Now, with a 2 there, that's the same as the square root. So I take the square root. Oh, sorry about that. So if we take the square root of 16 now, that's going to be 4 to the third power. And 4 to the third power is 64. For the next one with a negative exponent, remember that one is going to create a reciprocal. So 1/32 to the 3/5 power, like that. So now I rewrite that into a radical expression. That's 1/5 root of 32 to the third power. Okay, so if I do the 5th root of 32, that's going to be 1/2 to the third power, which turns into 1/8. Okay. So using a calculator to find our approximate roots here, we're just going to plug this in. Just make sure you're doing a rational power there and there. And then you can do your 4th root and everything there on that one. So plugging these in here, this will come out to about 1.552. This one will come out to about 2.539. And this one's about 4.30304. So just double check those on your calculator. All right, but that is it for our rational exponents. So take care, everybody.